What can you tell me? What kind of this electric field, Minashi? Is this homogeneous or uniform or non-uniform?
Uniform.
Yeah, it's a uniform electric field. So here we are considering only uniform electric field. So in this uniform electric field, if I put a charge, minus q charge, if I put a minus q charge, then this minus q charge will also experience a force. This minus q charge will also experience a force. Okay, and you know that force is equal to, due to minus q is equal to minus of q vector e. So this minus will give a force opposite to the direction of electric field. So for this case, the direction of this force is opposite to the direction of electric field, F minus q. F minus q, and that is F plus q. Means if you put an electron in external electric field, then what happened? That electron will move opposite to the direction of the field. And if you put a proton in external field, then what happened? That proton will move along the direction of the electric field. Because if there is a force, then what happened? It will accelerate. Okay, because if there is a force, then there is acceleration. Because if a charged particle has mass, means if I put a proton, okay, if I put a proton in this external field, if I consider a proton, yeah, this is your uniform electric field, and if I consider a charged particle, this is your proton. Suppose this is a proton. Proton has positive q charge and it has mass m, and you know the mass of proton is 1.67 into 10 raised the power minus 27 kilogram. Okay, and it has positive charge, means it has positive electronic charge plus e charge. So what happened when you put this proton in an external electric field E, then this proton will experience a force along the direction of this electric field, F of P. And that force is equal to charge of proton, that is plus E into electric field. Okay, electric field. If this proton, when this proton experiences this force, then it will also start accelerating. You can also find the acceleration. What is the value of this acceleration? You can find the acceleration by using equation ma. F is equals to ma. Okay, so from here you can find the acceleration, that is equal to e vector e divided by m. Okay, we did a numerical over this concept. Okay, so you can also find the acceleration. So when we put a charged particle in a electric field which has some mass, and in that case you can also find the acceleration produced by that force which is experienced by the particle due to external electric field. Okay, same if we put an electron in an electric field, here mass is the mass of proton. Okay. And again, if we consider a electron in this external electric field, if I consider electron in this external electric field, electron, so in that case this particle will also experience a force, but that force is, suppose this is F of E, that is the charge of electron is minus E, so minus E into vector E. So this minus sign will change the direction of this force, or you can say this minus appears because the force experienced by electron is opposite to the direction of electric field. So here the direction of electric field is, that direction of force is opposite to the field, This is your direction of this force. Okay, and again you can also find the acceleration of this electron that is also me into a, and from here you can find the acceleration, and that acceleration is equal to minus e divided by mass of this electron. So Minashi, can you tell me this acceleration is along the electric field or opposite to the electric?
For electron, it is opposite to the
It is opposite, and for proton it is in the direction of the
proton,
external electron.
same direction.
Same direction. Okay. So this is the conceptual part, that when you put a particle in external, that's important. We there are so many numericals based on this concept in your first unit, and in your second unit, second and third unit, both unit, you will get a lot of concept and numericals based on this basic concept, that when a charged particle put in external electric field. In your later chapter, you will also see that we put charged particle in some magnetic field. Okay, in some magnetic field. That's a different property, different topic, and that I will discuss in your chapter number, means I think 4 or 5. Okay, so I'm giving you a numerical based on again this concept. Some few numericals, not very tough, is the easy. So suppose I consider electric field. This is our electric field, and it's a uniform electric field. Okay. This electric field has magnitude of E is equals to, that is 25 Newton per Coulomb, and the direction of electric field is along I cap. And if I put a charge, of 5 positive 5 micro Coulomb, okay, then find the force experienced by this positive charge. Find the force experienced by this positive 5 micro Coulomb charge. Solve it. It's a very easy question. Mohammed Saifullah, you are very late.
I received the link just now, sir.
Okay. So only 2 of his students are present in this class. I think. So today actually I am just revising our previous concepts, because to start a new topic, at least most of students must be available. Okay, I'm just revising the previous topic, which is a charged particle in external electric field. So I gave a question that when we put a plus micro Coulomb charge in an external electric field, that has the magnitude 25 Newton per Coulomb. So you have to find the force experienced by positive 5 micro Coulomb charge. It's a problem based on our previous concept that I discussed in my previous class. Now try to find the force experienced by positive micro Coulomb charge. Yeah, Minashi, 125 into 10 raised to the power minus 6. So yeah, that's a correct answer. So its force is equal to is plus charge, means 5 into 10 raised to the power minus 6 Coulomb into 25, and the direction of electric field is I cap Newton per Coulomb. So this Coulomb gets cancelled out. In this case, you will get 225 into 10 raised to the power minus 6 I cap Newton. This is your force. Okay. Again, if I put this same problem, this time changing the sign of the particle, charge particle. If I put this charge particle as negative 5 microcoulomb, then what happened? What's the answer you will get? If I consider this particle as minus 5 microcoulomb charge, the direction of electric field is same, that is 25 Newton per coulomb, and the charge particle has charge of minus 5 microcoulomb. Then in this case, what is the change in
Minus
the answer?
125.
Exactly, the force you will get is 125 into 10 raised to the power minus 6 into that is minus I cap, or you can say opposite to the, means for plus 5 microcoulomb the force is like in this direction, 125 into 10 raised to the power minus 6, and for negative 5 microcoulomb the direction of this force is like this one, is a 125 into 10 raised to the power minus 6 Newton per Newton. Okay, so this is all about the problem. So I'm discussing again a problem that's a very good problem and very important problem. Okay, that there is a historical background of this problem. Okay, first I'm writing the problem, then I will discuss the solution. Okay, first I'm writing the problem. The question is, the concept is same, charge particle in external electric field. So the question says, if I consider a electric field, let me draw a region of electric field. Suppose this is your negative plate. Okay, and suppose this is your positive plate. Okay, so in this case there is an electric field. Suppose the direction of the electric field is from negative plate, positive to negative plate. This is the region of your electric field from negative to positive plate. Okay, let me draw a few more line, electric field line. This is your electric field. The electric field is uniform one. Okay, and finally, so suppose this one is your electric field, and what you have to do, yeah, so in this electric field, this one is your negative plate, negative, 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 negative. This one is your positive plate, positive, positive, positive. Then the electric field line, the direction of electric field line from positive to negative. So these are the these are the direction of this electric field line. The difference between positive to negative plate means the distance from positive to negative plate is y. Okay, and what happened? Suppose a charge particle q plus q enters in the a charge particle q, a charge particle small q enters in region of electric field E, with velocity v, and length of the plate is L, length of the plate is capital L. Okay, so what is given here? You know the length of this plate, means if the total length of this plate is capital L, okay, and means the total distance along your x-axis means length of the plate is capital L, and the distance between positive to negative plate is y. So you can consider it as in y direction or y axis the distance is y, and on x axis the distance is capital L. Okay. So question is, when a charge particle, suppose this is your charge particle, this is your charge particle, yep, this is your charge particle q. This charge particle enters, means it has some initial velocity, that's why it's entering in this field. So this charge particle when enter in this electric field region, okay, from here it enters from at close to the positive plate. When enters in this field region, then you have to calculate the time taken by particle. The first part of this problem is time taken by particle to cross the plate, and second part of this problem is y deflection of the plate, y deflection of particle, not plate, of particle. These are two part of this question. So again I'm repeating the problem so that you can understand completely what is the problem. The problem is simple, that there is a two different charge plate, one is positive, one is negative. So there is a electric field region between this plate, because electric field line rises from positive and goes to from positive to negative plate. Okay, so in this case the electric field behave as external electric field. This is not the electric field of this charge q. And suppose a random charge particle means, or you put a charge particle by initial velocity capital small v at close to the positive charge plate. So what happened when this charge particle q, enters, when this charge particle q enters, this is your particle, it has some velocity v. When it enters in this field, then what happened? It experiences a force. It will experience a force along. In which direction it will experience a force? Jasola, can you tell me in which direction it will experience a force?
Upward.
Yeah, it's a means in y direction or x direction? It's a positive q charge.
Y.
Yeah, y. It will experience a force in y direction. So what happened? It has some velocity, but it has velocity in x direction, and it will experience a force in y direction. Then what happened? It will follow a trajectory, means it will go like this. It will follow a path like this one. It will slowly cross this plate. Okay, it will go like in this curve, because it's moving in x direction and it's experiencing a force in y direction. Then what happened? It will go follow like this one, and after some time t it will cross the plate. Okay, so that's the problem, time taken by particle to cross the plate. And how much deflection means y, what is the value of this y? These are the two part of this problem. So first I'm going to solve the time taken by particle. Okay, so first note it down the problem, write the complete problem, then I will solve it. Note it down the problem. It's a very important problem, very important problem. Okay, so I'm going to the solution part. All of you, have you noted down?
Yes, sir.
Okay. Okay. So let's go to the part of the solution part. So here I will use the equation of motion because the particle is moving. So I will use equation of motion. There are three equation of motions, as you know, three equations of motions in your Newtonian mechanics. You studied three equation of motion. Okay, V is equals to U plus AT, and V square is equals to U square plus 2AS, and S is equals to UT plus half AT square. So I will use the equation S is equals to UT plus half AT square. So if I consider the motion, it's a two-dimensional motion, means the particle is moving along x direction and also in y direction. Okay, x direction due to its own velocity, in y direction due to electric field, due to force. Okay, due to force. Okay, so here the direction of force is upward because the particle is positive, so the direction of force is upward. If this particle is negative, then in that case direction will be downward direction. Okay, but this particle is positive, so the direction is upward. Okay. So motion along x-axis. So first the motion along, first part solution, that motion along x-axis, motion along x-axis. So if I consider motion along x-axis, then uh, then what's the force? What is the force along x-axis? How much amount of force experienced by particle along x-axis? Is there any force acting along x-axis, Minashi?
Yes, sir.
Is there any force acting along x-axis?
You no
Yeah,
no.
no, yeah, exactly. So no force acting along x-axis because the only force is force due to electric field, and that's in y direction. So no force along x-axis. So when there is no force, so there is no acceleration, no force, no acceleration. Okay, and as I told you, the initial velocity is u is equals to ux is equals to v. Okay, and the total distance covered by particle along x-axis is, Saifullah, the total distance covered by particle along x-axis is,
L.
yeah, it's a capital. So small x is equals to capital L. So here you can apply the formula S is equals to ux, Sx is equals to uxt plus half ax t square. So you can find the value here. Here your acceleration is 0. So that is your v into t plus 0. Okay. And what is the value of this Sx? Means the total distance covered in the direction of x. I have to write this Sx. That is capital L. So capital L is equals to v into t. From here you can find the time taken by particle to complete his trajectory, means to leave this plate. That is t is equals to capital L divided by v. That is the first part of this problem. Time taken by particle to cross the plate, that is t is equals to capital L by v. This is your first part of this problem, and I am putting the equation number 1. Okay, note it down, the first part, then I will discuss the second part. Is it clear? It's very easy, means we just use the equations, the conditions which we know from the figure, and we use equation of motion. We put this, we substitute values of this force, acceleration, initial velocity, and total distance, and we find the time taken by particle to cross the plate. Note it down. Then I will discuss the motion along y-axis, and from there we will calculate the deflection of particle, means the value of y. Okay, so I'm going to the next part of this problem, that is y deflection of the particle. So yeah, so I have to find the motion along y-axis. Motion along y-axis. Y-axis. Okay. So again, tell me, is there any force along y-axis? Saifullah, what do you think? Is there any force along y-axis? There is no force in along x-axis, but is there any force along y-axis?
Yes.
Yeah, it's a f of q means that's the force due to electric field, and that force is equals to is qe. That force is equals to qe. F of y is again your qe. Right. So if there is a force, then there must be acceleration, and that acceleration experienced by that particle. That's why it's moving in y direction. Otherwise, it will go straight along x direction. But if it's changing its direction of motion, means is then it has then it will experience acceleration, and that acceleration can be calculated via the value f is equals to ma. So here ay is equals to ffy divided by mass. Here mass is the, here m is the mass of the charged particle. Okay, it's not the mass of electron, it's not the mass of proton, it is a simple mass of the charged particle, that is m of q. I have to write it. Okay, m of is small q. Okay, or I should write here where m is the mass of charged particle. M is a mass of charged particle. Charged particle. Okay, so you have to put this value f of y, that is qe divided by small m. So from here you find your acceleration, which is a of y. Okay, you already know but how much time it take to cross this plate, that is t is equals to capital L by v from equation number 1. And in that case, is what is the value of initial velocity along y direction? There is initial velocity along x direction, that is small v. Is there any initial velocity along y direction? Minashi, what do you think?
Yes, sir. No.
Is there no, that's actually 0. So the initial velocity along y direction is 0. So here you can put the value, that is u of y is 0. U of y is 0. And the distance covered by particle along y-axis is small y, means s of y is small y. Here s of x is equals to capital L, and here s of y is equals to small y, and this small y you have to calculate. That's actually part of the problem. So again you can apply the formula, s of y is equals to uy t plus half 80 ay t square. Okay, here sy is your y. Okay, all the quantities you know uy, half of ay t square. You just have to substitute all this value in this equation and find the answer. Now try to find the answer, Minashi and Saifullah. Abdul Rahman, you are too late. Means it's 7:17. Okay. Amos Saifullah, find the answer. And Minashi, have you got the answer? Yeah, it's the correct answer, Saifullah. Abdur Rahman, I haven't start any new topic today. I'm just solving problems based on our previous topic, which is charge particle in external electric field. Because the strength of students is weak, so I just revise previous concept and I'm solving assignment actually related to charge particle in external electric field. Okay, maybe I will start a new topic on our next class. Nashi, have you got the answer?
Sir, I got 1 by 2 QE by ME into L by V the whole square.
Yeah, it's a correct answer. So both of you get the correct answer. So here the value of y is equals to uy. This part is 0. So plus half of ay. The value of ay is your qe by m, and the value of t is L upon V the whole square. That is the value of y. Y is equals to half of qe by m into L by V the whole square. This is your answer. This is the deflection of particle along y direction. Okay. This much amount of distance particle gets deflected. This expression is very famous and very important. J.J. Thomson, at the very first, J.J. Thomson was the one who found experimentally the ratio of electron charge and mass by using this expression. Okay, in this expression you can find the value of y. If you set experiment, means when you do after 12th, when you do your engineering or any degree in science, means whatever you do engineering, graduation in engineering or graduation in science, then you definitely you will do this experiment. That's we call E by M. You will do experiment in your lab that we call E by M. E by M is the ratio of electron charge and its mass. Okay, you know the charge of electron 1.6 into 10 raised to the power minus 19. You know mass of electron, that is 9.7, 9.1 into 10 raised to the power minus 31. But when you do experiment, this we call the famous experiment E by M, that was first done by J.J. Thomson. In that experiment, here you can see what is the value of E by M. Q is E, basically Q is a charge that for electron it's a small e, and M is the mass of this charge. So from here you can get this value Q by M. All the quantities you can know, means if you are doing experiment, then you can find the value of y, okay, through measurement, that what's your plate vertical distance, and you can also estimate the length of your plate, that is capital L. Capital L, you know. Y, you can know the electric field, applied electric field. The only thing, and this y is also known. The only thing you can calculate, that is we call E by M. That is equal to twice of y, v square, divided by that is EL square. By using this formula, you can find the value of this E by M. But in this experiment E by M, he also used a magnetic field. Okay, there is a CRD cathode ray tube. In that CRD, this experiment can be performed. Okay, so this experiment you will do in your higher studies, means when you do engineering or any course in science, any higher course in science related to physics. Okay, simple BSc, or I think bachelor in engineering. There you will definitely get this experiment E by M. Okay, so today I'm stopping here. The next class I will discuss the next topic, which I will discuss in our next class, is torque. We put an electric dipole in some external electric field, and we will calculate the dipole. We will calculate the torque experienced by that dipole. Have you guys studied what is torque? Maybe in your previous class, you studied the torque in rotational mechanics. If you don't know what is torque, then I will discuss in brief what is torque. Okay, and torque experienced by what is the value of torque when we put an electric dipole in some external electric field. That's the topic which I will discuss in my next class, that is on Monday. Okay, so if any doubt you can ask, or you can leave. Minashi and Mohammad Saifullah. Abdul Rahman, you can stay here. I will give a revision of this problem that I just discussed just now. Okay, so
Thank you, sir.
Minashi and Saifullah, you can leave, but you want to take a revision of this problem which I just discussed, so you can stay. Okay. Okay, Abdul Rahman, I am giving you a revision of this problem because it's an important problem. Okay. Okay. So in this problem, what we did, so you know, yeah, this is the problem. It's a very important problem. The problem is we have an electric field. In this diagram you can see there is a positive plate. I'm just removing some point that I will draw again. Yeah, so in this diagram there is a positive plate and there is a negative plate. The positive plate, yeah, this is your diagram. Yeah, this is your complete question. So there is a positive plate, there is a negative plate. So the direction of electric field from positive to negative. Okay, and the length of this plate is capital L, and the vertical distance between this positive and negative plates is small y, and the horizontal distance is capital. Okay, so the question is, a charge particle Q enters in region of electric field E. A charge particle Q enters in region of electric field capital E with velocity small v. Then if length of the plate is capital L, then you have to find time taken by particle to cross the plate. Okay, and y deflection of the plate. First, note it down the problem. It's an important problem. Note it down the problem. Then I will discuss its solution.
Sir, I'll take the screenshots. Can you explain now?
Yeah, that's good. So what happened when you put a charge particle Q here? Yeah, it's your charge particle. It's a positive charge particle, and it has initial velocity v. It has initial velocity v as given in the question. Okay, as initial velocity v. So when this charge particle enters in this external electric field, okay, then what happened? This charge particle will experience a force, as I discussed in my previous class, that when a positive charge particle enters in an electric field, then it will experience a force in the direction of applied electric field. So in this question, the charge particle is positive, so it will experience a force along the direction of this electric field f of E. Okay, f of E. This the direction of force is perpendicular to the velocity of, because the charge particle is moving along x-axis and it will experience a force along y-axis. Okay, then what happened? It will follow a path, means it will enter in this electric field, and due to this force it will follow a path trajectory, and after some distance it will cross this plate. After some time it will cross this plate, because it will experience acceleration due to this force. And what happened? Due to this acceleration, it will also follow some path along y-axis, and after some time it will cross the plate. you have to find the value of this small t when it will cross the plate. And the another part of this problem is you have to find the y deflection of the plate. Okay, y deflection of the plate means how much distance it will cover along vertical axis. Okay, so this is the problem. Is it clear? The problem is clear?
Sir, can you explain how the electrical field is opposite?
How electric field is opposite? Electrical field is not opposite, means the charge particle, as I discussed in my previous class, that when particle has positive charge, then it will experience a force along the same direction of the electric field. Let me go to the little bit up. So yeah, so charge particle in external field, what happened when we put a charge particle in the direction of electric field, when you put a positive q charge particle simply, then it will experience a force in the same direction of the electric field. And when we put a negative q charge, then it will experience a force along opposite to the opposite direction of the electric. This is a concept, very simple concept, the behavior of charge particle in external electric field. So positive q charge experience a force in the same direction of the field, negative q charge experience a force to the opposite direction of the field. Okay, so here in this problem you can see the plates, the electric field is along y-axis, the electric field along y-axis, so the force experienced by this particle is along also y-axis. If this particle is negative, then it will experience a force along negative y-axis. I think it was your problem.
Yes, sir.
Is it clear now?
Yes, sir. Sir, what about the force?
What about the force? What is the magnitude and magnitude of the force? That's you're asking?
No, sir, the direction.
The direction. I'm saying that the direction is along y-axis. The direction of the force, as I'm drawing in figure, it's along y-axis. Okay, so you can write here. So the direction of force along y-axis. Okay, is it clear now? Because the direction of electric field is also in y-axis. Okay, Abdul Rahman, is it clear now?
Yes, sir.
Okay, so now we can go to the first part of this problem, that is time taken by particle to cross the plate. So I'm using the equation of motion as you studied in your previous class, means class 11. There are 3 equations of motion, and I am using this equation of motion as is equals to ut plus half at square. So first I'm considering motion along y-axis, because the particle is moving in 2-dimensional plane. It's is moving along x-axis as well as along y-axis. So first I'm considering the motion along x-axis. So as you know, there is no force along x-axis. The only force which is experienced by particle is along y-axis. There is no force along x-axis. So Fx is equals to 0. When there is no force along x-axis, then it means it will experience no acceleration along x-axis. So for that, acceleration is also 0. Okay, and as you know, the initial velocity of the particle is small v, and the vertical distance covered by this particle is horizontal distance covered by this particle is Sx is equals to L, because the total length of the plate is L, capital L. It's also given. Okay, so by using these 4 quantities, means force, acceleration, initial velocity, and Sx, we put all these values to the formula. In this formula, Sx is equals to ut plus half at square. Acceleration is 0, so this part will 0. Only you will get is Sx is equals to Vt, and you know what is the value of Sx? Sx is your capital L. So from here you can find the time, which is t is equals to L by V. So this amount of time, which is L, this is simple. Okay, distance upon velocity, the simple time, because there is no force in along y-axis, x-axis. So that's why you can estimate time by simple L upon V. Okay. Is it clear for motion along
Yes, sir.
x-axis?
Clear.
Yeah. So now next, this one is the first part. The second part is motion along y-axis. So what happened? For calculating motion along y-axis, as you know, there is a force along y-axis. There is a force along y-axis, which is the force Fy is equals to QE. Okay. And due to this force, the particle will also experience acceleration. So acceleration is equals to Fy by m. Simple. F is equals to ma. So from here you calculated the acceleration Fy by m. And you know what is the value of y is QE by m. So here the value of acceleration is QE by m. Okay. We calculated the acceleration because we have to use the equation as is equals to ut plus half at square. So here you get the idea of acceleration, which is ay is equals to QE by m. Next, what you calculated is small t. You already calculated small t, means time taken by particle to cross the plate, that is capital L by V. You also calculated the you also know the initial velocity along y direction. What is the initial velocity along y direction? Tell me, Abdul Rahman.
0, sir.
0, exactly, because there is no motion initially. Particle is not moving along y-axis. Okay, so initial velocity along y-axis is 0, and the total distance covered by particle along y-axis is small y, which you have to actually calculate. So when you substitute all this value in this formula, as y is equals to uyt plus half ayt square, you know the value of uy, that is 0. This part is 0, plus half ay, the value of ay is QE by m, and the value of t is L by V. When you substitute all the value, then you get the answer is y is equals to half of, it's a very important problem, QE by m into L by V the whole square. L by V the whole square. So this is the value of y. Okay.
Yes, sir.
Is it? So that's all about it. Today's lecture. I will discuss the new topic in my next lecture, means on Monday. Okay.
Sir, for how much marks can this be asked?
Yeah. What's first question?
Sir, for how much marks can this question be asked?
This question can be asked in your full mark question, means big question. Full mark. It's a large question. It's a derivation. It's not a problem. It's a full derivation.
So, sir, 4 marks.
Yeah, it's a maximum marks, means 4 marks. Okay.
Okay, sir.
Put it down. So okay, so we will meet in our next class. If you already
Okay,
taken the notes, so we can close this session.
thank you, sir.
Okay, welcome.